So let M be the vector space of 2 by 2 real-valued matrices and M equals ABCD. We need to define M star as DBCA and to characterize matrix M such that M star equals M inverse. So basically to do so, for finding M inverse, we want determinant of M to be not equal 0. So that matrix M is invertible. That means that determinant of M equals AD minus BC. So AD minus BC does not equal 0. Well, now let's look at M inverse. M inverse equals 1 over determinant of M, which is AD minus BC, times D negative B negative C A. Well, now this expression has to be equal to M star, so let's write that down. So M star equals M inverse. That means that M star, I'll just copy paste it, equals M inverse now let's multiply both sides of our equation by AD minus BC. So here we will get AD minus BC times DBCA matrix. Here we will get 1 over AD minus BC times AD minus BC, just 1. So here we just have D minus B minus C A. Now let's do scalar multiplication on the left side. So here we have D times AD minus BC, B times AD minus BC, C times AD minus BC, and A times AD minus BC. And this equals D minus B minus C A. Well, now since these two matrices are equal, then all of their values need to be equal. So that means that D times AD minus BC equals D. It also means that B times AD minus BC equals negative B. It also means that C times AD minus BC equals negative C, and A times AD minus BC equals A. Well, in that case, we understand that either A equals 0 or D equals 0 or both. So A equals 0 or D equals 0 or both. Then AB minus BC equals minus BC, and it doesn't equal 0. Then B and C are both non-zero. In that case, AD minus BC equals negative 1. So M star, so let me highlight this. So M star equals M inverse if either A equals 0 or D equals 0 or both, and AD minus BC equals negative 1. So let's write it down. When A equals 0 or D equals 0 or both, and AD minus BC equals negative 1. So this is the first scenario. The second scenario, if A and D do not equal, so second scenario, if A and D do not equal 0, in that case, AD minus BC has to be equal 1. We get this from the first equation, from this one. So AD minus BC equals 1. Then B equals negative B and B equals 0. Similarly, C equals negative C and C equals 0. So M in this scenario, M looks like AOOD, with AD being equal 0. So this is our second scenario. So our solution, our answer to this problem consists of these two parts.